What does that mean?
Is that dA over dt?
Exactly. In this case, is dx over dt because we denoted by x, but it doesn't matter if you want to denote it by a. It's perfectly okay. So it's indeed dx over dt. dt because it's in time measured in seconds, and dx because we're talking about x. If it's okay if you want to denote it by a, it does not matter. Excellent. So I established that, and now I have to come up with an area, a function that represents the area of the square. And I have to remember what is the formula for the area of a square.
Pi r squared.
Pi r squared is the area of a circle.
Times width.
Yes, but since they are both the same,
Length or width squared.
right, so it's x squared.
Oh.
If they are the same, x times x is x squared. Copy the base, add the exponents. Perfect. Now I'm asked to find how fast. What does that mean? What am I looking for? And this is what we've studied in this course so far. All about the same thing over and over, over and over. A change. Which means we're looking for,
Delta x?
correct, but
Just the derivative.
exactly. Very good. So we want dA over dt. Remember, this is a variable. This is a variable. X is a function of time. It cannot be treated as a simple variable. It's a function. So we want how fast the area is increasing, meaning dA over dt. So let's differentiate. In other words, I'm differentiating both sides. I get on the left-hand side dA over dt, because A is a function, area is a function of time. And on the other side, what do I get? It's exactly what we just did with the previous problem. No change at all.
2x.
Yes?
Oh, 2x times dx over dt.
Yes. Because x is a function. Very good. It's done. All I have to do now is plug it in. So dA over dt equals 2. X is given to us as 20. And dx over dt is given to us as 10. So I have 400. The measurement unit is extremely important. Look at these two and tell me what is the measurement unit.
Millimeters squared per second.
Very good. Indeed. So let's differentiate implicitly. So this is topic 3, implicit differentiation. So let's differentiate something like p to the third plus 2p minus 4x squared equals 10. All the same thing. They want us to determine dp over dx. So this is a function of x, this is a function of x, this is the variable. I didn't put a dot underneath because it's not a function. I put a dot underneath so I don't forget that it's a function. You don't have to use this method, or just write on the side, this and this and this and this are functions. That's fine too. So this is another way of expressing that something that may look like a variable is actually a function. Or you just write it down. Good. So, can anyone differentiate? It's the same thing. Implicit differentiation, related rates, they're exactly the same topic. Can anyone implicitly differentiate the left-hand side and the right-hand side?
This would be 3p squared times dp over dt
Excellent. Plus.
plus 2 times dp over dt.
Excellent. Minus. Oh, I'm sorry. It's x this time. Good. Minus, and this is just a variable.
That's 8x.
That's it. And the right-hand side is
0.
0. Perfect. Now, this has to be transferred to the other side, and here I have to factor out dp over dx because these are not like terms. And the right-hand side is 8x. So now, what do I have on the left?
Three p squared plus 2.
3p squared plus 2. And finally, dp over dx equals
8x over 3p squared plus 2.
this is it. Okay. Any questions so far? Topic number 4. Absolute max min on a closed, meaning this, interval. This is what we mean by closed interval. So let's say we have f of x equals 3x to the third minus 3x squared minus 3x plus 10, and the closed interval is -1, 0. We have to create that table with f prime and f of x on such a question. And we have to put in the table just -1 to 0, nothing else. We have to determine what next?
Critical numbers.
Yes. In other words, we have to find the derivative. Excellent. Yes. And if the critical numbers do not fit here, we cannot put them in. If it's 5, I'm not going to put them in. I mean, I cannot put 5 in the interval -1, 0. So I have to find the derivative. I have to set it equal to 0 or undefined and find, if any, critical numbers here. Good. Can anyone differentiate this function for us?
Be 9x squared minus 6x minus 3.
Good. Perfect. Thank you. Now, obviously, I have to, number 1, set it equal to 0, and number 2, set it equal to undefined, but this is not possible because it's a polynomial function. Don't start trying to factor and so on and so forth. When you solve the equation, just put it in the calculator. So, here it is. If your calculator doesn't have this feature with the apps and number 9, polynomial root finder, please ask to borrow a calculator for the duration of the test. So get a calculator from the testing center. So punch in carefully the coefficients. We have 9, we have -6, and we have -3. So don't waste your time trying to use the Corati formula, There is no need for this. So -0.33 is in the interval. So this is -1/3. But 1 is not. Don't bother with it. okay? So that you can only put the negative 1/3 in the interval, right? Is that clear? Negative 1/3 fits in the interval, but 1 does not. So we found that x equals negative 1/3, and we found that x equals 1. Perfect, but it doesn't fit here. All I have to do now is find the sign left and right. When I plug in 0, see, the sign is negative. When I plug in negative 10, you will see the sign will be positive. That's all you need. So we determined, in this case, only one critical number that fits. I study the sign of the derivative, and now I have to put the function in and find these values. And this side, it better be increasing from this to this, and on this side it better be decreasing, otherwise there is a mess up here and I have to start from scratch. So if these numbers are not in sync with this sign of the derivative that I just determined, I will have to say, oops, something is wrong. So I go to the graphing calculator, I punch in the function, the original function. So go back to y equals, clear whatever, it's in there, and put 3x cubed, and put minus 3x squared, minus 3x plus 10, and then all I have to do is punch in 3 numbers, nothing else. Negative 1, 1 divided by 3, oh no, sorry, negative 1 divided by 3, and 0. That's all I care about. So the first one gave me 7. The next one gave me 10.6. And the last one gave me 10. If these numbers that I just determined are not in sync with the sign of the derivative from 7 to 10, yes, that's okay. From 10.6 to 10, that's okay. So now I have to identify the absolute max, absolute min. I also like the relative max, relative min, but the problem is only asking us to determine the absolute max, absolute min. So 7 is right here, 10.6 is right here, and 10 is a little bit below. This is not the graph of the function. I'm just putting the values in so I can discuss. So this is the highest, this is the lowest, and this is somewhere in between. That's all I'm showing here. So what would you say about negative 1, 7? What type of point is negative 1, 7?
It's an absolute minimum, but not a relative.
Yes. Absolute minimum, it cannot be relative because it cannot be at the end of the interval. Excellent. What about negative 1/3, 10.6?
Both absolute and relative max.
Yes. Absolute, relative, max. What will you say about 0, 10? It's not the highest, it's not the lowest, and since it's at the end point of the interval, it cannot be relative. So this is nothing. Nothing. At the end point of the interval, we can only have an absolute max or an absolute min. I already have the absolute min. I already have the absolute max. Yes, we can have the same value and we can have 2 absolute max and 2 absolute min if they have the same height. But in this case, this is somewhere in between and it cannot be a relative because it's at the end point of the interval. Therefore, that is nothing. So this is how we address absolute value, absolute min, absolute max on a closed interval. Any questions? Any questions? Okay, topic number 5, graphing. Rational functions and polynomial. Okay, so let's take a look at one function. Like, for example, let's say we have f of x equals 7x to the 5th minus 3x to the 3rd divided by 2x to the 4th plus 7x to the 3rd. This question is only asking us if this function has a horizontal asymptote or not. So let me refresh your memory. Type 1, type 2, type 3. Rational functions. I'm talking about rational functions now. Rational functions. Type 1 has degree n over degree n. Same degree. This one has a horizontal asymptote. What is the horizontal asymptote? How do we determine it? Well, it's the leading coefficient of the leading coefficient. So here's an example. If I have f of x equals 3x plus 1 over 4x minus 2, same degree, degree 1, same degree, degree 1. The leading coefficient is 3, at the top is 3, at the bottom is 4. The horizontal asymptote is y equals 3/4. If it's type 1, if it's same degree over same degree, if it's type 2, degree n, degree greater than n. This is always easy. Horizontal asymptote is y equals 0. So, an example, f of x is 1 over x. The numerator has degree 0, the denominator has degree 1. So a higher degree in the denominator than the numerator, that's all it means. The horizontal asymptote, you don't even have to calculate it. It's a waste of time. If the degree is higher in the denominator, we know the answer is always positive at it's always 0 at positive infinity or negative infinity. The last one, no horizontal asymptote. What is the last one? Type 3. Well, that has a slant asymptote. How does it look? So it's degree n plus 1 over degree n. What does it mean? If the degree in the denominator is 5, the numerator has degree 6. If the degree in the denominator is 10, then the degree in the numerator is 11. It must be 1 unit difference, higher in the numerator than the denominator, just by 1 unit. Okay, so now, which type is this? If it's type 1, I will say whatever. If it's type 2, I will say 0. If it's type 3, I will say hell no.
That one's type 3.
Exactly, because the numerator has degree 5 and the denominator has degree 4. So there is absolutely no horizontal asymptote. Not possible. This one has a slant asymptote. So the type 1 and type 2 are the only ones with a horizontal asymptote. The first one has to have same degree over same degree. They don't. The numerator has degree 5, the denominator has degree 4. The second one has to have a higher degree in the denominator, not the numerator. So it's not type 2. It is type 3. And type 3 does not have a horizontal asymptote. Okay, so this was just about the horizontal asymptote. Now let's look at the graph situation. Any questions on this so far?